I've been at Modern for 2 years. I'm an AI research engineer there, which means I get to do all the fun new stuff and plug it into the technology that we already have. So just so I can get an idea of the room, who here is familiar with Open Rewrite? Who's familiar with Modern, the company who built and created Open Rewrite? Okay, so a good chunk. So I'll be talking about how we integrate AI into our product and how at the end we can deliver more features to our users. But I really wanted this talk to be an inspiration on how you can bring AI into various parts of your pipeline. So no matter what field you work in, I definitely think there's going to be similarities of where you'll be able to plug in your AI. Is the sound annoying for anyone? No? Louder? Okay, I'll be louder. All right, so the title of the talk. We have AI's Big Leap, not Al's Big Leap, from psychic to autonomous multi-repo refactoring powerhouse. So let's get right into it. So what is this talk not going to be about? It will not be about dumping millions of lines of code into an LLM and then hoping for the best. That's not how we do things at Modern. We don't think that just by plugging it in and hoping for the best, you're actually going to get good results. We actually think there's going to be information behind the lines of code that is going to be actually useful. So we're trying to move past the idea that code is only text. There is information that needs to be leveraged behind. So what do we have here? We have code as data. So yeah, we have the abstract syntax tree. Who here is familiar with the abstract syntax tree? All right, so a couple. So basically the idea is when you compile some code, you have some information about what the variables actually mean. So for those who do any language engineering, you'll be very familiar with this. So you can see how quickly from a very small bit of code, just a couple lines, we actually end up having a pretty big tree here. So that's for the abstract syntax tree. If you maybe have a keen eye, you might see that I've scratched it out. Well, the reason why is because we actually do lossless semantic trees. So what we do with lossless semantic trees, we basically take this data. So we have this abstract syntax tree that we use as the foundation and then add in a bunch of information. So if you have comments in your code, the AST wouldn't necessarily keep that into its data structure. But in the lossless semantic tree, it does. Same thing for type attribution. This is information that otherwise would have gotten lost. But with the lossless semantic tree, we're able to go and gather that information and use that to advantage later. So type attribution, think that if you have just a method declaration and you have an argument of type cat. We all have cats, at least I do. Well, what do you actually know about cat, about this class? You might not know that maybe cat extends the class animal. And so with the lossless semantic tree, we're actually able to keep that information, and that will later help when we actually make either migrations or search or impact analysis on our code. So see this here? This is an idea of a lossless semantic tree. This is actually really, really pruned. I believe this is only maybe a depth of 1 or 2 into the lossless semantic tree, but it's just to give you an idea of very simple code. I believe this was a repo of only a couple files, maybe about 50, and how quickly it grows, but that's just how much information we actually have. So what can we do with these lossless semantic trees? Yeah, they're pretty, they're cool, but if they're not useful, I don't care, right? So we can actually do migrations. So what we have here on the left is a visualization of what a migration might look like. Now, I know it kind of looks like trees, but this is now a complete different thing. Every single dot that you see inside of that tree here structure is a recipe. So what is a recipe? A recipe is something that can make a change to a code. It's a predefined set of instructions to change code. Or it can be for searching as well. But for this example here where we migrate to Spring Boot 3.4, you could imagine the little dots being very precise instructions about what to do to your code. One of them might be, maybe you would want to upgrade a version of a Gradle dependency. That would be one of those dots that you would see at the edge of the tree. So let's go see what that actually looks like so we can actually play with it and look inside. make this bigger. So I have the same recipe here, migrate to Spring Boot 3.4, and you can see that this thing is massive. So every single dot is a change, and we can just click one, randomly. What is this one? Well, I just talked about it, upgrading to the Gradle dependency version. Now you might wonder, what is this little cluster here? I actually don't know, so let's click into it. Let's see, can I get the middle node? I don't know if I'll be able to. Yes, I was able to. So here we have migrate Spring Boot properties to 2.0. So you might see that all these recipes are kind of nested into each other. So as much as I said that every little dot is one instruction, you can actually have composite recipes. So recipes that are composed of multiple recipes. Say I wanted to upgrade every Gradle dependency to version 1.00. Well, that would be a little bit of a silly migration, but it is something I can do, and I can just have one recipe that says upgrade or change all the versions of my Gradle dependencies to 1.00, and I would have a list of recipes inside of that. So that is basically the idea here of what you can expect to see as at least in the amplitude of how many changes you need to do to migrate your code. To the slides. So as you saw, a lot of steps, 3,371. So let's talk a bit more about these recipes and what can they actually do. So I kind of like when I start explaining them to someone who hasn't used a recipe before to divide them into 3 categories. So we have on the left, we have our search recipes. So those are just examples. We have many, many more. But this idea is almost a Lego block of a search. If you want to find a method invocation using a certain method pattern, you don't need to rewrite this recipe each time you have a new method you want to search for. Instead, you want to use a modular recipe, a Lego block of a recipe, as I like to call them, that you can change and add an argument to. So this is exactly the same recipe you would use to find usages of Apache Commons or usages of Spring Boot or any other library that you might be interested or even something that you wrote. So that's the idea basically on the left is you have these blocks of a recipe that are able to be changed and used to whatever you need to search for. So we have find types as well, which work similarly. We have deprecated methods, that kind of stuff. Then in the middle, you'll have those change recipes, but that are, again, very much Lego blocks, that are things that will be used to compose bigger migrations. So we have the change method. If you wanted to change all your methods, foos to bars, that's the one you would use. And again, you are able to add in options or arguments to a recipe because why rewrite the same thing? So when you look more on the right, though, that's where you see those massive trees, the one I just showed before, where you actually have these huge migrations, these thousands of steps to get your code migrated to whatever version. So we talked about AI, and we're still not there. So we have this slide that we like a lot that I stole from my colleague, where basically it has happened before. We saw it with multiple different technologies over the years. You can think of microservices. You can think of crypto. This will often happen, right? You kind of have this this thing that's going to be everywhere on your LinkedIn, and it's going to be everyone saying, well, are you using this? Are you using that? That's the great new technology. And then you're like, wow, there's so many things we could do with that. That would be amazing. Well, that's, a little bit where we started with AI, especially AI applied to code. So fortunately, you kind of end up going down the roller coaster, and you end up in this lull, right, in this phase where maybe you think, okay, well, it doesn't work well, maybe it demos well, but is it actually useful? Does it make so many mistakes that I end up not using it? Does it have too many false positives? Well, hopefully you persist and you end up here. And that's what I'm hoping to show you today. So we talked about adding AI to different phases of your pipeline. So to be able to kind of ground what our pipeline looks like for a code base until the end of once it is actually migrated, this is what it looked like, right? So we take all the files, we have to first parse them. So we use the build tools to figure out, okay, get all that extra information inside the lossless semantic trees, which we then see on the second step. Finally, on the third step, well, you actually need to make a change or search for something, so that's when you would apply a recipe. So you apply a recipe onto an LSD that has already been parsed. And finally, if the recipe does produce any change, you would have diff files that you can then do mass PRs with. And finally, you can profit with your newly beautiful code that has been modernized and has a new haircut. So that's basically the idea. So where can we bring in AI in different places in here? Well, how about right here in the first step? So we basically, this is more specific to us, but when we get a customer's code for the first time, we're going to set up a process called mass ingest, which is basically where we build all their projects to get all of these LSTs and later serialize them and be able to actually run them on our platform. So this step, as you can imagine, can be pretty complicated. There are so many different build tools. Within those build tools, different features, different versions, and there can be sometimes failures. So what we wanted to do is, can we use AI to make our life more easy on this front? What initially was an internal tool ended up becoming an external tool that everyone could use. So let's look at what this actually looks like. So this would be the result of running a cluster. So don't worry so much about the X and Y. Just think that if two dots are close to each other, they are similar. So every single dot here represents a build log where there was a failure. So you can see that there's kind of these little clusters of dots next to each other. The idea was, can we use this data, this visualization, to prioritize which repos we should look at and see if maybe there was just a version missing, a dependency we had to add. And if that error solves, 50% of the build failures, then let's maybe fix that one first instead of going one by one, those that only fix a couple. So if we look at a couple of these, and pardon me, they're a little bit small. I am not a UI designer, so this is what it looks like here, but I will read them out loud. So here we have basal list not found. So that was the error here, and that's for one build failure. So if we move a bit more to the right, well, we have the same error here. And if we go look over here, what do we have? Well, there was an error here. There's a Gradle wrapper version 221 is not compatible with init Gradle. And all of these are going to be the same here. We can expect the same thing over here, where here the thing didn't work because of Maven, and these are all Maven failures over here. So maybe Maven would be something you'd like to look at first, as you see that there's about, I want to say, 60 dots over here. And then you'll have your others over here. All right, so how do we actually run this? How do we get to this result? I like to show the result before actually going to explain the theory behind it, so like that you can kind of visualize what's the end product, what do we actually want. So we use something called embeddings. Who here is familiar with the term embedding? Okay, perfect. So embeddings are basically numerical representation of an entity. So that entity could be code, it could be images, it could be videos, it can be text, it can be one word, it can be a sentence. Really, it's just as long as you have a model that is trained to take that type of input, you can get an embedding at the end. So an embedding is going to be a list of floats, and really you just got to think of them as a numerical representation. The idea with embeddings, as you saw in the previous example, where when two dots are near each other, so when two embeddings are near each other, and that you can use, cosine similarity, you can use distance, Euclidean, really, then it really depends on what your model was optimized for. But basically, you have this list of floats that mean something, that you're able to use to represent something. So that might be a little bit vague, so let's go with an example, and I think the timing is perfect because I'm getting hungry. So I like this graph a lot where we can imagine here an embedding of size 2, right? Where the first number would be used to represent the dessertness of a food. And you would have the second dimension, which would be for the sandwichness. So here we can see that hot dog and shawarma are very near each other, and that hot dog, I'm sorry for those who say as a sandwich, is a little bit more in between a sandwich and not a sandwich. So that's basically the idea. And we can kind of see that if we were to cluster them together, well, it'd be kind of easy to maybe say, okay, we'd have the bottom stuff would be one cluster, and then we'd have our apple strudel all alone. But of course, if we were to add ice cream or maybe even an ice cream sandwich, then maybe we would have a different types of clusters. So that's basically the idea. So all you need to really understand about embeddings is that they're just used to basically so that we can do math with representations of things. And that's really the gist of it and the important part for what we're doing. So when we look at the clusters, this was really useful because we were able to be a bit faster, basically, at getting the number of repos ingested into the platform for our customers. And that's a tool you can keep on reusing and run multiple times and keep getting these new clusters and basically find what to prioritize. So even though we might often think of AI as something that's being used for generative AI, for like the end part of your pipeline, it's the final thing that we see. It's actually pretty useful also at the beginning stuff. And clustering and embeddings is a technology that's been here for a while. It's not new. OpenAI didn't invent it. So it's definitely something that you can add, and there's going to be a lot of resources online. All right, so now recipes that use AI. So here's another part in our pipeline. So let's see where we are here. If we go back, well, it would be probably, right on the recipes, right? So if we think of recipes, these open rewrite recipes, as maybe the train or the train tracks, we have basically this predefined framework that can help us walk through our code, right? So when we were looking for searching for method invocations, we have recipes that can do that, right? Recipes that can go through your code really quickly, efficiently. So what if we have open rewrite as the wheels? We can even make them spin. Now, forgive me for not doing all the wheels. I just did the first two, and I hope that's okay. So since we have this train, this super efficient train, what if we added AI on top? And this is basically the idea here of recipes that use AI. We have this framework, let's use it. And again, that's transferable to any other application. If you have a framework that works well, use it and then plug in AI. Don't try to rebuild your wheels. Your wheels are already there. So it might be a little bit hard at first to understand how a recipe actually works. So I have this very, very, very simplified LST. This is not actually how it looks like, but for the sake of simplicity, we can go over here. So how does it actually work? It works thanks to what we call the visitor design pattern. So if we see the wheels as basically this train tracks that helps you visit every part of your code, what if we start first at the method declaration? So what the recipe is asking itself at every single point as it's walking down your code, as it's visiting your code, it's asking itself, based on where I am in the code. So in this case, right now, it would be in a method declaration node of type, a node of type and method declaration. It might want to ask itself, okay, well, what am I trying to achieve here? If we want to visit every comment and basically delete them because we're statistical and we want our colleagues to hate us, then maybe we could use a recipe like that. So let's use that example here where we want to delete every comment. So the idea is that as you're walking through the code, you're inside the method declaration and you might ask yourself, all right, so do I want to continue walking down the tree? Is my job done here? Do I want to maybe just look at what the type of method declaration is before I continue walking down? So since we're looking for every comment, well, we want to say, no, keep walking down the tree. There might be comments later. So we now visit the first line, and it just so happens that the first line of code also has a comment. So what we can say is, all right, now that we're inside a node of type line, let's maybe decide, do we want to continue or not? And you can see now the theme a little bit. We finally end up going to the comment. And now that we're inside the comment, we can ask ourselves, was there something I wanted to change in the code over here? Well, yes, I wanted to delete the comment. So that would be something you could do here, where you basically rechange the LST and you change what's inside that node of comment to be able to, when you unparse it, you'll get the diff and you'll be able to make the change. So that's how a recipe works. So when we have, basically, to go back here, when we have recipes that use AI, it's basically the same thing. So we actually had a customer who is in Quebec, and so a lot of their code is in French. And for those who know French, there are often accents on letters. So what happened is because they had really, really old code that had went through various phases of its life, there was some encoding errors. And so a lot of their comments basically replaced accents either with a question mark or even worse, with that little diamond with a question mark inside of a UTF-8 encoding error. So that is annoying for readability, but at least you can kind of guess what the word was, but that wasn't the worst part. The worst part is that their Java docs would not compile. They basically didn't get documentation for these projects, and if it failed on one method declaration, it failed for the whole project. So as you can see, this was basically something we need to fix really quickly. So we decided, well, why not use AI, right? This is not something we can deterministically decide what is going to be the word that's going to be there. That's going to replace the one that has the question mark or the UTF-8 not encoded character. So it's the same concept here. We just walk down the tree and we ask ourselves, am I in a comment? Is there a chance that I might see a comment if I keep walking? Yes, there might be. Okay, finally I'm in a comment. And now I can say, okay, well, let's look at what actually the content of that comment is. If there's no misencoded character, I don't want to do any changes. But if there is, that's when I would want to make a change. And that's exactly what we did here. So I'm sorry, this might be a little bit small for people in the back, but you can just take my word for it. We fixed it basically. So this is just a demo repo, Spring Boot Clinic for those, Spring Pet Clinic for those who know it, where basically I added some errors in how it was usually seen in our customer's code, and you can see that we have the diffs ready to be published. So this is very useful. They can now have test cases as well. It just made things better. All right, so what else can you do with AI used inside of recipes? Well, you can also do knowledge graphs. And I don't know for you, but I'm seeing RAG everywhere on LinkedIn. I feel like RAG was the word of LinkedIn for 2024. I believe knowledge graphs is going to be the LinkedIn word for 2025, so write it down, guys. So what can we actually do with this? So instead of having just a model that's ready to be called whenever we might need it inside the code, what if we can use a model to generate extra information about the code? So we already have the train tracks, right? We already have that train walking down the tree that has access to all this information thanks to the lossless semantic trees. Can we add more information here? So that's exactly what we did, basically. So in the first two steps here, we have for every method declaration that you see in your code, we go and find extra API examples. So if I declare a method name, add reply, maybe I would want to see how is it actually used? What do I actually mean by reply? That gives us a lot of information about this. So the first step is actually just being done by another recipe. So within a recipe, you're calling another recipe. Really, the sky's the limit. When you have a framework that can take you in a very organized manner through your code, you can then be able to call basically another recipe. And so that's what we did. Then we wanted to say the same thing for method declarations, but why not find unit tests as well? Because that will give us even more information of how we were expecting add reply to be used. So that's another recipe that we had that we are able to call. All right, so what about the AI part? Now you can see the two little robots in the last two dots here. Well, what if we used basically the results from the first two steps? So we have unit test examples, we have API examples. Maybe now it's time to actually just generate very quickly a description using this extra information that we went to get. Well, we can do that by calling an LLM and saying, we want you to give us back a response that looks like this. So we have description, pretty easy, description of the returned value. So maybe add reply returns a string, but maybe it also returns something a little bit more complex, like an object or something that you've defined somewhere else, and that thanks to the type attribution, it'll be able to get that information. And finally, it might be useful to see techniques. So maybe there was encryption that was added in add reply. Maybe there was logging. Maybe there's stuff that you wouldn't have thought about adding to the description that might be useful for later steps. Once we've done that for every method declaration, we can actually then go get, very similarly, descriptions for every class. So we're able to use basically all the information that we have from every method declaration within a class and get our own now summarized information about it. So similarly, we'll have a description. Then we'll have a responsibility. Maybe this is a controller. Maybe this is a factory. And we'll also have the patterns, so the design patterns. We'll have, what exactly is being happened there inside the code here. So this is all nice to have. It's great to have this information. What does it actually look like? So when I told you we were going down the tree, that's when you're able to see, okay, at different parts inside the tree, do I want to add this information and want to store it, basically. So when we're done running it, it will look like this. So this recipes have this is not super important for this talk, but basically with recipes, once they're done running, they will produce a data table that you're able to download. So it's more than just diffs. We also need to sometimes see the information, especially if you're doing a search recipe here. So similarly here, we'll have a data table, and again, I'm using Pet Clinic as an example, and you can see kind of what happens. So this is for the classes, basically. So we'll see, okay, well, this is the welcome handler, or we'll have the person data, or the base entity, owner management, all that kind of information. So I don't know if you guys are starting to think a bit like me, okay, what next, right? This is nice to have, but I know how to read code mostly. Well, there's going to be an extra step after, and this is where it actually gets really interesting. When you want to search now for something inside your code, well, that's kind of vague. You don't really know what you're looking for. It's not a method pattern. You can't just plug it in. Well, this is now information that is going to be really useful. If I wanted to ask, where is the customer's data getting encrypted, I can use now this information over here. So kind of as a toy example, one of the first things we wanted to do with what can we do with this, this extra information, we wanted to see, okay, well, can we update a README? It's not necessarily our shtick. We're not really big on generating code in that manner. But it was just like, we have so much information now that we've gathered from the LST and that previous recipe. Can we run another recipe that uses this information, this knowledge graph, to basically generate a README that's more useful? So that's exactly what we did. So I'll show you an example. Might even have it already here. Yeah. So I read it here on Pet Clinic, and I asked over here, I said, add emojis that represent each class defined. So what's nice is that once you have this final information all ready to be sent, we send that again to an LLM, but this time we actually give it a task. So we say, all right, now I said, just as a fun example, I said, all right, we'll add an emoji for every class. And that's basically what I did here. But then the sky's the limit, right? So we actually use it on one of our repos. So all our recipes are going to be within their own repo. And there was one repo that didn't have a very good README about what it contained. So we asked it, we said, go look at every class that extends a recipe from open rewrite and describe to us what the recipe does. So that was really great, is that we even had a filtering that was added on top where we said just focus on the ones that extend recipes from open rewrite. All right, so I don't know if you guys follow us on LinkedIn, but we have some good news. And so far I've talked a lot about, where in the pipeline can we actually have AI be added here. Well, I did talk about, having all the different places basically where you can add AI. And what if our whole platform was AI? I'm joking, that would be way too much. But if we do want to be able to meet the user wherever they are. And that's a bit where we came from with what we call Modi, which is our agent. So I know that recipes, this whole concept can be sometimes a little bit daunting to understand at first, especially with only 45 minutes. But that's why we wanted to kind of meet the user wherever they were. So we have this agent, basically, that has access to all the tools, that understands all the tools, and that can now call them for you. So you don't need to know now, what exactly is a method pattern? How do I define that? What was, again, the options or the arguments for this recipe? You can now just converse with the agent that will then run the code for you. So this is exactly where we're at. So we have different tools, basically, that Modi has access to. It has access to searching for recipes, right? We have this huge catalog of predefined recipes, whether it's more of those Lego blocks recipes or the actual big migrations. it will be able to search basically based on the user query. So if I say, okay, we'll update my code to Spring Boot, it'll be able to look, okay, let me see what Spring Boot recipes I actually have in the marketplace. Similarly, then it can run the recipe using the right arguments based on your query. So the upgrading to Spring Boot might not have arguments, but if I'm searching for all usages of Apache Commons, then I would want basically a recipe called find methods, which then has arguments in them. And finally, the most fun part is that then you can just discuss about the results. You don't need to download the data table, go make some Excel spreadsheets, and look at how it looks. You can just talk. And that's really what we wanted to do here. So let's go look what this actually looks like, because otherwise it can be a little bit vague. And this is where we pray to the demo gods. All right, so this is basically the platform for those. If you're curious about trying it out, you can just log in using your GitHub. And basically, we have a bunch of open source repos there that you can run any type of recipes and kind of explore what we have. So let's look at what I have here. So I have here one recipe selected. It's the Spring Pet Clinic. And let's look maybe, what kind of Spring API endpoints do I have in my code? So what's the first thing it'll do? It'll basically search for the recipe, right? So this is what we have here, where we have all these different recipes. And surprise, surprise, as if I had planned for this, there is a recipe called Find Spring API Endpoints. So that's what we wanted to run. So it'll be able to run this recipe here. So we can still go look if we want to use the old system of what this recipe actually looks like. So if I go over here and click, I can basically see the recipe running, and when there's going to be results, I'm going to be able to look at them here. So that's the idea here. We can still see everything that we need to see from the old way, but if we just want to converse with the model, then we can just go over here. So it's running the recipe in the background. We'll see when results will come. All right. It's a pretty quick one normally. So anyways, just to continue with this example while it's running in the background. So basically then you'll be able to converse about, all right, well, what was the most common Spring API endpoint? Maybe we want to do any changes finally. So here we have some results. We have 6 results. It's a pretty small repository here. And if we go back to the chat, it'll be able to summarize that for me. So we can see here that it's able to summarize, and I can chat and say, which one was the most common one. And I'll be able to keep chatting and basically see the results from that. So that's basically the idea here. And what's nice is that you don't have to have that mental load about choosing the recipe, what arguments do I need to put, and you also don't have to have that mental load at the end of actually analyzing the results. So how this can maybe translate to other people's features or products that they're trying to do. Here, yes, it's fun to have the LLM, and it's always flashy, and it's great to talk and all that. But the actual brunt of the work is the product that we know and we've built for many years and is battle-tested, the recipes. So what is actually making the changes? What is actually searching for things? It is the recipes themselves. So we know they work. We know they've been tested on millions of repos. And that's why it's much better than using just an LLM and give it basically the lines of code one after the other. We have this data. We have the LSTs for every repo. Why not use this data instead? Let's go beyond just what we see in the IDE. And this is really where now we can actually use a product that we know. So if you have anything that you want to add to your chatbot and you want to add tools, I recommend stick to what you know works. I'm sure all of you have amazing products and things that already work and is battle tested. And this is basically what you want to give. So in the same way you wouldn't ask, an LLM, what's 532 times 724, you would say, hey, use this calculator that I've built over the years that I know works really great and is super efficient, instead of having it just spur out, a best guess, basically. So that's the idea here, is that we want to basically give the recipes to do the grunt of the work and to finally have the LLM kind of do the end part, the polishment of running the recipe and being able to discuss them with the recipes. So that is it for me. We're going to get to questions in 2 seconds. I just want to show a couple things first. If you're interested in how we do AI, I definitely think we have an approach that's interesting, that's very grounded in between being a mix of deterministic and non-deterministic. I just realized the slide is still in French, so maybe you've heard that from my name, but you could have guessed I also speak French. But basically, this is a free book that we wrote. There will be a new version also coming out soon where we talk more about the knowledge graphs and MADI. But we try to really give information more about what's actually the architecture behind, and we try to give tips about how to build efficiently in a way that is iterable, that you can basically learn very quickly as you're building, kind of like landing the plane as you build it, or vice versa, building the plane as you build it. And okay, well, the marketing and sales folk would not forgive me if I didn't talk about Code Remix. So we have this first edition of a conference, basically. So if you like Open Rewrite, if you like Modern, if this is something that maybe you would like to add to your pipeline, then you can come and see us. There's going to be days that are going to be reserved just for coding, so it might be interesting for you guys. Thank you very much, and now I'm going to take some questions.
So how much variation in results do you see? If you were to run the same
recipe?
Same code base twice,
yeah.
do you see any variation?
So the question was, for those who still want to listen, basically when you run a recipe, you'll always get the same results. It's true that maybe if there's any vagueness in what you're asking, so say what would be a good example? If I'm looking for lists inside my code for method invocations, then maybe the first time I ask MADI, it might think, oh, well, you want Java util list, right? Something like that. Well, maybe I was actually talking about something else in my code, or I was just talking about any list method in any code. So there might be variations in that, but that'll always stem from any vagueness in the query, basically. Yes? This one? Oh, perfect. Any other questions? Yes?
So regarding the security of the own code base, right?
Yes.
So you guys learn on our code base or something that you run, right?
Yeah, exactly. We do. So the question was about security, about having customer code bases. We do not do any training on the code bases. That's not our shtick. The code itself has enough information using the lossless semantic trees that we don't need to do this training, basically. We are able to just supply the information that's already in there to the LLMs. We don't need to fine-tune the LLM on anything. And we're SOC 2 Type 2 for all the other reasons.
So no reading the code base, sending it to central repository.
No, exactly. So we connect an SCM basically through our platform. So we'll have private instances for some customers. Some of our customers are banks, insurance companies, where their data needs to be really safe. So then we'll connect basically through their SCM through that, and they'll have a private instance.
Private instance within the organization?
Within your own thing, but we should ask then someone else. Kevin, can you answer that one? So the private instance, are they within our organization? No, they're within the customer stuff, right?
So we spin up for each customer, we spin up a single tenant instance, and then your code gets encrypted in your LSD format, enters our area. It's a SaaS solution.
Yeah.
There's an on-prem non-SaaS solution as well.
Yeah. But then you might miss some of the AI features if you don't do the SaaS.
So what is the license?
What's that?
What is the license period?
Yeah. You can also stop by our booth and we'll talk to you about
Yeah, absolutely. Please do. Any other questions?
Does it work with COBOL?
With COBOL? So yes, a little bit, yeah. So we do have recipes for COBOL, like searching, some very simple, like the Lego blocks will have some of those, basically. So then what's nice about the LLMs is that we don't really care how the data is, how the LST is built or what the recipe is. We just get the results at the end. So it basically makes it very iterable on how you build it. So yeah, we do have recipes for COBOL. All right, well, thank you, everyone. I'll stay here for a couple minutes in case there's more questions.